Hello guys, this is Paul McWhorter with TopTechBoy.com, and we are here today with lesson number 16 in our incredible tutorial series where you are teaching the robots who's boss. I'm going to need you to pour yourself a nice hot cup of coffee. Ah yes, that would be strong black coffee, no sugar, no sweeteners, none needed. You can see that I've made the transition from iced coffee to hot coffee. Yes, it's a little bit cold here in West Texas right now, so I have made the transition for the duration of the cold weather to coffee that is hot and black. But as always, you don't need any sweeteners and you don't need any sugar. Okay, it has been a little while since I've made a lesson in this video series. I queued up a bunch of lessons over summer and then school started and things have been really busy around here because with this world that we're living in with the outbreak and everything, things that used to take 5 minutes at school now take 30 minutes, and I just have not had the opportunity to put any lessons together. But the good news for you is that I've got a little bit of a break now and I am going to queue up as many of these lessons as I can because I have really enjoyed this series of lessons. So what I am going to need you guys to do is get out your robotic gear, and as you're getting out your gear, as always, I want to give a shout out to you guys who are helping me out over at Patreon. It is your support and your encouragement that keeps this great content coming. But enough of this shameless self-promotion. Let's jump in and talk about what we are going to learn today. I'm going to teach you how to use the most excellent HC-SR04 sensor. And what this sensor is all about is it is about, maybe before I tell you, I should ask you a question. What do these three things have in common? Bats, whales, and submarines. And don't say that they swim underwater because bats don't swim underwater. No, bats, whales, and submarines. And what the answer is that they find things and they navigate by a process called echolocation. And the way that works is, let's take a bat, for example. A bat is flying around and he's flying around in the dark. He wants to see what is out there. He emits a little chirp that is unique to him. He emits the chirp goes out, hits something, comes back, and he hears his chirp coming back to him, and therefore he can gauge how distant things are in front of him, whether it might be a juicy little moth that he wants to eat or the wall of a cave that he is about to run into. But bats are incredibly adept at navigating in the dark using this echolocation process, sending out a ping, waiting for the ping to return, and then judging distance based on how long the ping was away. Whales do the same thing. It's just a much lower frequency, but they identify things because they're underwater in the dark, and they send out a noise, and then they wait for that noise to bounce back, and then they hear it. And as far as man-made things go, the submarine works the same way. If you've ever watched one of the old submarine movies, you hear the little ping, ping. That is actually an ultrasonic transducer. It is sending out a ping, and then it is waiting to hear the reflection of that ping back off of a target. And based on the amount of time the ping was away, it can judge the distance. Well, this then gets us to our work today on the most excellent Elegoo smart car. You guys that don't have your gear yet, look down in the description. There's a link over to this smart car robot that I will be using. Helps if we are following along on identical hardware. But what we've done so far in this series of lessons, in the first 15 lessons, we've gotten to the point that we've calibrated the car and we can drive it. We can send it forward, we can turn it left, we can turn it right, we can return it. We can operate it based on little the little IR remote. We found the little IR remote doesn't work very well, but then we also found out that we could control it using the most excellent BLE Bluetooth module and control it from our smartphone. And what we found is using the little Bluetooth module in the smartphone, it works much, much better than using the little infrared remote. But this series of lessons is about learning. We started by learning the infrared remote, then we learned the Bluetooth application. Now that is great for kind of having a toy that you can use your phone and you can drive around, but in a real application, the robot needs to not run into things and needs to understand whether it is about to run into something or not. And so the way we're going to do that is we are going to do that with echolocation. And I will get out of your way here. And what you can see is our most excellent Elegoo smart car has mounted on it this HC-SR04 ultrasonic sensor. And the way this sensor works is just like the bat, just like the submarine, just like the whale, what it will do is when you send a command, it will send a ping out and then wait to hear the return of the ping after it bounces off of a target. I guess you could not see that. I need to get over here a little bit more. So let me see if I can kind of show you that with a target. So let's imagine this is the target and this is the sensor. The sensor sends out a ping. The ping goes to the target, comes back, and then the sensor hears that ping. And then depending on how long the ping was away, you can judge distance. And if you program this up into your smart car, then the smart car can figure out whether it has an obstacle in front of it or not. Now, what we're going to do today is we're going to just basically get the sensor up and working. We're going to learn how the sensor works, and we're going to send out that ping, and then we're going to see how long it takes for the ping to return, if that makes sense. Okay, so I guess one of the things that we have to sort of see to get started on this, there are, if we look at the front here of the sensor, you can see that it's pretty easy to hook up. You've got VCC, which is the input voltage. You have ground, which of course is the ground, and then you have the trigger pin and you have the echo pin. Okay, you've got the trigger pin and you've got the echo pin. The trigger pin is what sends the ping, and then the echo pin is what listens for the ping. And the way you send the ping is you first of all make sure that the trigger pin is low, and then you send the trigger pin high, you delay, and then you send the trigger pin low. When that trigger pin makes the transition from high to low, that's when it launches the ping. Then what you want to do is you want to see how long that ping is out there before it comes back. And you do that by listening to the echo pin. And so the echo pin, you do a pulse in on it. The echo pin is going to be high as long as the ping is gone. When the ping returns, the echo pin is going to go low. And so there's going to be a high pulse on the echo pin, and the echo pin is going to be high as long as that ping is out there. So we think about trigger pin. It's low, we send it high, and then we send the trigger pin low. As soon as the trigger pin goes low, the sensor launches the ping, and now the echo pin goes high because the ping is out there, and the echo pin stays high until the ping comes back, and then the echo pin goes low. Now, if we just look at how long the echo pin is in the high state, that will tell us in microseconds how long the ping was gone. So one of the important things is to understand that echo pin, we're measuring it in microseconds, which isn't too useful for us to come up with, useful numbers. So we're going to have to translate that into a more useful number. But right now we're just measuring how many microseconds from when the ping was launched until it comes back. I hope that makes sense. I've done a whole lot of talking there, but I hope it makes sense. We're trying to measure how long it takes for the ping to go out, hit the target, and come back. Now, one of the kind of curious things that is a little annoying is, you know, we can't just go in and hook this up any old way that we want. We can see that on the back of this, if I can get it where you can see it, you see we already have a cable harness coming from the ultrasonic sensor, and then it is coming over here to, man, it's like it wants to be behind me. I think I am going to have to focus this for you, so give me a second, because this is kind of important. And I will come over here and I will give you a manual focus. Okay, there it is. So what you can see is that harness from the ultrasonic sensor comes over and it hooks on the Arduino board to +5 volts. That makes sense. To ground, that makes sense. And then it is connected to analog in pins A5 and A4. And to me, that's a little bit of the goofy part of this, because I would really, I don't like using input pins as output pins. I really like to reserve those pins when I'm doing things. I like to reserve those pins as analog in pins because they're unique. But it looks like what Elegoo has done is, instead of using the general purpose input output pins, the GPIO pins, the digital pins 1 through 13, they have chosen to hardwire this into the analog pins 4 and 5. And so normally I wouldn't do that, but since they're hardwired in, that is how we are going to have to do things. But knowing that, it's really pretty easy to do. So what I need you to do is come over here and fire up a brand new Arduino IDE window, and we are going to start coding. We are going to start coding to make this little sensor work. So we're going to have to start out by setting up some pins, and we're going to do that by declaring our variables up here at the top. Let me see if I can give you a little better view of this. Okay, that's a pretty good view. That's a pretty good view of the old smart car. All right, so we're going to come over here and we're going to set up some pins and some variables. So I'm going to do an int, and what 2 pins are we going to have to set up? There's going to be a trigger pin and an echo pin. So the trig pin, if we trace those wires out, and I encourage you to do this, but if you trace out those those wires, you can see that the trigger pin is connected to A5. And similarly, if you trace those wires out, you can see that the echo pin is connected to A4. So now we've kind of defined our pins. And now what we are going to do is we are also going to need a variable, and that is how long is the ping gone? What is that ping time from when the ping is launched to when it hits the target and comes back? And so I am going to define that as, let's see, I'm just going to call that ping t for ping time, and I'm not going to put a value in it because we will actually measure that. Now we're going to come down to our void setup and do our pin modes. Now this is kind of the strange thing. We're going to do a pin mode on the trig pin, and we are going to make it an output because that is how we are going to trigger the sensor. And then we're going to do a pin mode of the echo pin, and it is going to be an input because we are going to be reading from it like that. And then, as always, we need to start our serial monitor, so I will do a serial.begin and the old trusty 9600. I don't know why there's such faster baud rates now, but back in the old days, fast baud rates weren't very reliable, and so you kind of just get in the habit of doing the old faithful 9600 for the baud rate. So that looks good. And then what we are going to do is we are going to have a really simple void loop down here. What we're going to do is we're going to read ping t, and we're going to read it from a function that we are going to call ping time. Now there's no such thing as ping time, so we're going to have to define it here in a minute, but we're going to go out to our function ping time, and we're going to bring back from it that ping travel time, and then we're going to print it out. So here I will then say serial dot dot print ln, and then what am I going to print? The ping t that I just measured. Okay, and then I'm going to delay about a half a second before I make another measurement, just so it doesn't go so fast that we can't read it. Okay, so what this is going to do is it's going to read a ping and print it. Read a ping and then print it. But now we've got to teach it. We've got to teach it this function, this ping time function here that we're calling. And so I'm going to come down here after the void loop, and I am going to make it an int function, and I'm going to call the function ping time. Now this is very important. We haven't done a whole lot with functions, but the function has to start after the void loop ends. So this is where the void loop starts. This is where the void loop ends. And so this ping time function starts after the void loop ends. And then you are going to start that function with an open curly, and you're going to end that function with a closed curly, and it already put the end in there. Now I'm going to need a variable to put that measurement inside the function, so I'm going to define an int of ping ping travel time. Okay, so now I have a variable to make the measurement into, and now I've got to launch the ping. And the way I'm going to do that is I'm going to start with digital write, and then what am I going to write? I'm going to write the trig pin, and I'm going to write it low. Now hopefully it was already low, but just to make sure, it's going to be low. So I set it low, and now I'm just going to wait there for a second to give it a time to get low. I don't want to, as it's still trying to go low, send it high. So I am going to delay microseconds. Delay, it should have turned orange. Delay microseconds. Okay, it turned orange. That's nice, the little happy orange. And so now I'm going to delay microseconds. About 2 microseconds should be enough. Okay, and now I'm going to send the trigger pin high. So I'm going to digital write to trig, and I'm going to send it high. Okay, and now I'm going to keep it high about 20 microseconds so that you have a clear pulse. You don't want to just go zoom like that so fast that maybe it doesn't actually do it. Maybe capacitance or something, it wouldn't actually get up to the high state. So we want to make sure that it is high, so I will do a delay microseconds, the happy little orange, and I'm going to delay about 20 microseconds to make sure I've got a good sharp pulse. I'm in that high state, and now we're ready to launch the ping. We are ready to release the ping. And so we do that by now setting the trig pin low. So now I will go trig low, and it is that transition from the high state on the trigger pin to the low state that will release the ping. Okay, so now the ping is released. Now what do I want to do? I want to sit and listen and see how long the ping is gone. And I do that by listening in on the echo pin. And the way we do that is we're now going to say ping travel time. That was the variable that we set up. Ping travel time is equal to pulse in. And what am I going to be looking at the length of that pulse? I'm going to be looking at the echo pin, and then I want to know how long is that pulse what? High. Okay, I want to know how long the pulse is high. So it goes high as soon as I launch the ping, and it stays high until it hears the ping comes back, and then it goes low. So that echo pin is going to go up, and it's going to go out, and it's going to come down, and it's going to stay up as long as the ping was away. So ping travel time is equal to pulse in of echo and the echo pin and how long the echo pin was high. So now I have the ping travel time. What do I want to do? I want to return it to the main void loop. So I'll return ping travel time. Okay, so let's see how this works. When I call ping time, it comes down here, and then it calculates ping travel time. It returns ping travel time, and then the ping travel time will be put in ping t. And so now ping t will be that measurement of the ping travel time. What is the chance that this is going to work? I don't know. But I am going to have to go back and ask you guys to hold your breath on this one because I really want it to work. So let's take a big old swig of hot coffee and let's see if we can download this puppy. All right, I go. Boom! Look at that. The happy little blue bar. None of the unhappy little orange. We have successfully downloaded the program. Now that doesn't mean that it works, but that just means that it is downloaded. Now let me see if I can move this over here so that you can actually kind of see what is going on. Okay, and so I kind of have the ultrasonic sensor pointed over here. It's something that's probably about 8 inches away. So let's look at this and let's open up our serial monitor, and it is saying 1,395 microseconds for the ping to go from here over to here over to here. Now that actually kind of looks reasonable, but now let's see if we can change that, and let's see if that ping travel time, now as I get closer, ping travel time should do what? It should get smaller and smaller and smaller, which it is doing, and then when I come back it is getting bigger and bigger and bigger. Boom! We are measuring ping travel time and it looks kind of reasonable. So let's say that I'm here at about 1200. If I come halfway back, we come to about 600. And so if you just look qualitatively, it really looks like that this is sort of working. And it worked the first time. Man, I've got this obsessive compulsive behavior that I like to see if I can make a video without making any mistakes and everything download. And we had a good day today. I think that deserves another shot of coffee. So you can kind of see proportionally that the distance to the target is kind of proportional to that ping travel time in microseconds. So this is what your assignment is. Your assignment for next week is to take that ping travel time and turn it into a distance in inches. I need you to take ping travel time and change it into a distance in inches. So it should read like from here to here, it should read about 8 inches. Okay, so it should tell you a calibrated number for how far you are from the target. Okay, now if you're in college or you're like a really good high school student, you should be able to do this on your own without hints. Okay, but if you're just getting started and aren't real well versed on this, I'm going to give you a couple of hints. But you guys that are college students or really adept, I want you to skip these hints and see if you can do it on your own. Then I want you to leave a comment down below. I folded up like a cheap lawn chair. I couldn't do it at all even with the hints, or I was able to do it but I had to take the hints from you, or I did it completely by myself without looking at your hints. Okay, so if you don't want the hints, pause the video right now. I'll have a sip of coffee. Okay, for those of you who want hints, here's a hint. Okay, distance is equal to rate times time. Distance is equal to rate times time. So if you want to calculate a distance, it's equal to rate times time. Now what is the time? The time is ping travel time. What is the rate? Okay, I just gave you one hint. Distance is rate times time. Okay, if you want 2 hints, here's the second hint. Okay, here's the second hint. The rate is how fast the ping is moving. What would that be? I'm sending out ping. Ping is what? It's a sound. So rate would be the what of what? The speed of sound. You can look it up. All right. Now, I'll give you a third hint. The problem is that when you look up the speed of sound, it is going to give you the speed of sound in miles per hour. And you are not in the units of hours, you are in the units of microseconds. Okay, and also you don't want to measure distance in terms of miles. You want your distance to be in inches. Okay, so then here's kind of like the third big hint. You're going to have to do dimensional analysis. If you don't know how to do that, go and look up on my channel the video that I did showing you how to do dimensional analysis. But if you just use miles per hour for the speed of sound and you're in microseconds, you're not going to end up with distance in inches. You're going to have to do the dimensional analysis to change this ping travel time, which is in microseconds, and speed of sound in miles per hour to end up with an answer that is in inches. And so I have given you a whole lot of hints there. So you need to go away and you need to figure out how to turn this ping travel time into distance in inches. And what I will do is in next week's video, in the most excellent lesson number 17, I'll go in and I'll kind of go through the math with you and go through the analysis with you. And then the coding, I will tell you the coding is really going to be pretty easy. The coding will be pretty easy to do this. Okay, guys, I am really excited to be back here with you guys. I've missed making these videos, and I know some of you guys were getting a little anxious about the amount of time before I posted another video, but I want you guys to know that I'm back on the job here. I will make some more of these, and we'll have some more fun with this. Okay, guys, this is Paul McWhorter from TopTechBoy.com. If you like this lesson, give us a thumbs up. Think about sharing it with other people. Think about subscribing to the channel. When you do, ring that bell so you get notifications when I have new videos coming out. And as always, really appreciate you guys who are helping me out on Patreon. I've kind of lost a lot of Patreons in the last couple of weeks because of, everybody's got a bunch of pain on their own. And so if you guys could help out, I would really appreciate it. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.